Hello and welcome to lecture 13 where we discuss how IPOP now also handles layer 2 in the so-called switch mode. So far we discussed IP over P2P, and it turns out that many applications do work and only expect IP, but there are also applications that can benefit from a layer 2 virtual network from a performance perspective, as we'll see in some examples. So since version 15.01, IPOP supports a so-called switch mode. So you can think of this as Ethernet over P2P or ETHOP, but we like the name IPOP instead and we just call it switch mode. So some motivations and use cases. The key idea here is that you can start bringing multiple LANs together. IPOP, as we described so far, assumes that you're running IPOP on the endpoint. With switch mode, it's possible now to run IPOP on a router. That could be a software router, that could be a hardware router running, for example, the OpenWRT version of Linux. So for example, suppose you have clusters on multiple locations and you want to bring them together as a single virtual cluster. Switch mode helps doing that. Suppose you have multiple wireless LANs from multiple users who you want to bring together in the same virtual network. Switch mode helps with that. Or multiple VMs in a single host of a cloud provider, or multiple containers in a single VM of a single host of a cloud provider. And the key idea is that with switch mode, we do not need IPOP to be on the way of every single communication that happens within a local area network. So if two containers are communicating with each other in a single host, they don't have to go through IPOP at all. Or if two physical machines on the same wireless LAN communicate to each other, they don't go through IPOP. So that means that also there's no packet encryption and encapsulation and tunneling, but the assumption is that within a local network you may not want to do that anyway because it causes a performance degradation. IPOP does get in the way when messages go across LANs. So it will work as described earlier, pick a packet from a virtual network interface, encapsulate, tunnel, forward, encrypt. But now we're going to be looking at layer 2 frames and not layer 3 packets. So this allows us to support protocols that sit on layer 2, for example, ARP, the address resolution protocol. So the overall approach right now only supported by group VPN. And this mode, which can be configured in the configuration file, group VPN nodes will behave as a virtual Ethernet switch. So instead of looking up IP addresses, we're now going to be looking up hardware MAC addresses for the layer 2 protocol. And now we also need to worry about broadcasts. So IPOP will capture an L2 frame and look at whether it's broadcast or not. If it's broadcast, it forwards to all its local links. So currently this approach assumes the proactive mode in group VPN as described in the previous slide. It needs to be extended to support a general topology, but that's not yet in place. If the frame is unicast, then as we've done earlier, we look up a relationship between the destination and which link it should go to. But now in switch mode, the destination that looks up is by MAC address, not by IP address. But the same approach applies. It's just one layer below. IPOP will also capture an incoming layer 2 frame and will add to the table, its table, what is the source MAC address for that frame and what tin can link it comes from. So much like an Ethernet switch, IPOP learns which MAC addresses are on each side of a tin can link and builds these tables dynamically. So here's an illustration. Now, in the typical setup, you would have, like in this example on the top, you would have 5 nodes connected by, let's say, a group VPN. But here, in switch mode, each one of these IPOPs is really an overlay switch that could be bound to multiple endpoints, multiple virtual machines, for example, connected by a bridge. So let me guide you through an example of how we would handle a message that follows the ARP protocol. ARP is used to establish a mapping between a layer 2 Ethernet address and a layer 3 IP address. And this is used when a node wants to send a message over the IP protocol, he needs to first discover how to send a message through the layer 2 link. So in switch mode, IPOP will forward all broadcast frames, and ARP will send broadcast messages that IPOP will simply forward through tin-can links. So, for example, node A with this IP address and this MAC address wishes to send an IP packet to node B. So A will broadcast a ARP message of the type who has IPB on a LAN. So all the nodes in the LAN will listen to that message, but only B will reply that says, oh, I have IPB, and this is my address. So A will now start using the Ethernet address that it received from B to be able to encapsulate IP messages and send at the link layer from MAC address E to MAC address, MAC address A to MAC address B. So how would that work on top of IPOP? So suppose a node on this side of the network is sending an ARP request. So let's say this virtual machine with this address wants to send a message to a virtual machine with address 10.100.0.3. It's going to place that broadcast on this Ethernet segment. Now VM2 does not have that address, so it's going to be silent, it's not going to reply. But that message also will go to the IPOP tap. And that in turn will forward, capture and forward this message to all the neighbors that this is connected to. So at each neighbor, that Ethernet broadcast for the ARP protocol will be delivered. So let's suppose that 10.100.0.3 is in this network here that's highlighted. In the other networks, that ARP message will simply be ignored. But on this network, there's somebody, there's a VM with this address. And it's going to take that request and say, oh, it matches my IP address, so I'm going to send a reply. The reply is in the ARP protocol destined to the source, and it's going to establish this mapping. And again, IPOP will capture this packet, will send the ARP reply back to the source, and on the source, the ARP reply is going to be placed on its local Ethernet segment. And eventually VM1 receives a reply and understands that 10.100.0.3 now maps to this layer 2 address, MAC3, and anytime VM1 needs to send a packet to 10.100.0.3, its Ethernet layer will map to this MAC3 address. And then again, it's going to go through IPOP, encapsulated, tunneled, and delivered to the destination, just like with regular IP address handling. But now we're mapping and tunneling layer 2 packets instead of layer 3 packets.